Okay, so I'll just go ahead. My name's Sydney Gourlay. I'm with the LSMS team at the World Bank. And today I'll be sharing some of the work that I've undertaken together with Talib Kilic, who some of you know, on unearthing the drivers of the gender gap in agricultural productivity, longitudinal evidence from Malawi. And you'll see soon that this is a pun on soil. There's a large body of literature that shows gender-based productivity gaps in many countries across the Africa region, where female-managed land can be anywhere up to 66% less productive than male-managed land in the region. And UN Women estimates that by closing this agricultural productivity gap, over 400,000 people could be brought out of poverty in these three countries alone: Malawi, Tanzania, Uganda. So closing this gap could have very significant policy implications. And there are different channels, kind of different components as to why this gender gap exists. It's not simply because women are poorer farmers, of course, but there's two different mechanisms. One being the endowment effect, which is differences in inputs. In this case, it's typically driven by differences in chemical input use, cash crop cultivation, and access to male household labor, where women generally have fewer of these important inputs. And then there's also a structural effect, where female farmers might have differing returns to these inputs relative to male farmers. In most of the literature, the endowment effect really explains the majority of this productivity gap. Some work by Talib and Amparo show that the endowment effect can explain up to 82% of this productivity differential in the case of Malawi. However, so there's this broad literature with pretty consistent cross-country evidence, but generally differences in soil quality have not been very thoroughly explored. And this is, I suspect, I hope, largely due to data gaps, where high-resolution soil data sets with national coverage are really very limited. You have small-scale experiments with soil measurements or on-farm trials, but these are pretty small scale. On the national scale or broader geographic coverage, you have geospatial soil data, but these are at resolutions that may not be sufficient for the type of agricultural analyses we want to conduct. Okay. So with this background, we set out to do a couple of things. Well, a few things, as you can see. The first is to compare plot-level soil measurements with geospatial data to address first this question of, are geospatial data sets, are they enough? Are they high enough resolution? Are they capturing the variability? And as a small spoiler, we see they do not. So we move on to step two, which is constructing improved estimates of plot-level soil parameters through survey-to-survey type imputation approaches. So we're leveraging soil samples collected on the ground, geospatial soil data, and national household survey data. And then finally, the ultimate objective is to be able to analyze the role of soil quality in explaining these observed gender-based productivity differentials. We're using a lot of different data, I think 5 different data sets, kind of 3 different categories of data. So we're using methodological survey experiment data that, from 2 studies conducted in Uganda and Ethiopia, conducted by the LSMS group at the World Bank in partnership with the National Statistics Offices and the World Agroforestry Center, or ECRAF. So in these sub-national methodological studies, we collected soil samples, and we analyzed the soil with the help of ECRAF in Nairobi. So, and I should mention these are also georeference plots. So for these, we have objective soil measurements, georeferencing, and then some survey data to go along with that. Then on the National Household Survey side, we use data from Malawi, from the Malawi Integrated Household Survey Panel, the IHPS, and we're using 4 rounds of this data, 2010, 13, 16, and 19, where we have, of course, nationally representative longitudinal household survey. This, again, is implemented by the NSO, the National Statistics Office, with support from the LSMS team. And we have very detailed, I think many of you here are familiar with the LSMS studies, but we have very detailed plot level information on agricultural activities. And we also have georeferenced and GPS measured plots. And then finally, the last category of data that we're using is geospatial soil data products. And we use two different kind of digital soil mapping products for this research. The first is Soil Grids. Sorry, it's difficult to see in this color here. Soil Grids 2.0, which is a 250-meter resolution digital soil product produced by ISRIC, and then also the ISDA soil, which is a 30-meter resolution digital soil map. And we essentially extract soil parameters from these two geospatial products based on the georeference plot locations in the Uganda, Ethiopia, and Malawi studies. So to start, to kind of set the scene as to why we need to go on with this kind of prediction approach, we compared the geospatial data with our plot level measurements. So here's just a table of means. And you can see that the plot level, which are the measured properties, are statistically different from the kind of the raw geospatial products, the soil grids and the ISDA, for these key soil parameters. So we're seeing differences. You can see also in the scatter plots where we're comparing the plot level measurements with the geospatial product. There's really not a very satisfying alignment between those different measures. So this it kind of encourages us to go forward with our prediction model approach. So talking about the methodology, we're essentially estimating OLS regressions of plot level soil parameters that are measured in Uganda and Ethiopia as a function of geospatial-based soil attributes, and then plot and household characteristics from the household survey data. We assess the out-of-sample model accuracy using a randomly selected 30%. And then we're also separately are looking at the robustness of these predictions using some machine learning approaches. For now, I'll focus on the OLS approach. So we're estimating these regressions and effectively applying the model coefficients to the same set of parameters, the same set of soil attributes and survey data for Malawi, right? Because in all of these surveys, we have the household survey data and the geospatial soil data. So we come up with a kind of a calibrated plot level soil attribute for the Malawi data. And then using these different parameters, right, these are estimated for separately for some key soil parameters separately. So organic carbon, nitrogen, soil pH, and clay. Using these, we follow the literature and we construct a soil quality index to make it also a little bit more tenable. So we'll have a soil quality index from our plot level measures, and then a calibrated soil quality index and kind of the raw geospatial based soil quality index. Then we take those into our productivity and decomposition components to assess the performance of the calibrated soil index relative to these raw indices. Right. So we do this cross-sectionally, but here we'll focus on the panel regression using household fixed effects, where we're estimating agricultural productivity with our emphasis being on the coefficient around the soil quality index. Then following that OLS, the productivity analysis will take it to a Oaxaca blinder decomposition to decompose this gender gap, the gender gap that we see, into this endowment effect versus the structural effect. So I won't go too much into detail on the Oaxaca blinder methodology, but effectively we're able to parse out the share of the gender-based productivity gap that we observe into what is coming from differences in endowments versus the structural effect. And we'll focus on the endowments, specifically around soil. So to show you some of our initial results, this table here, which is probably extremely difficult to read, is the kind of shows our prediction models. This is for soil grids. Separately, we have the same for ISDA. With the key takeaways, right, we're estimating these for different soil parameters separately. And what's important is that we do see a positive relationship between the geospatial soil property and the measured property. So, for example, organic carbon extracted from soil grids is a significant predictor of our measured soil carbon. That's good news, it's as expected, but we do see differing levels of explanatory power. We also see some significance coming from subjective soil assessment, which is part of the household survey. And these are often included in agricultural surveys. So something that could be used in other contexts. We get a range of R-squared values coming from these predictions, from about 34% for soil pH up to 62% for organic carbon and total nitrogen. And you see we get a little bit of additional leverage, let's say, coming from the ISDA data, so the higher resolution soil data. We get a bit of a stronger R-squared for carbon and clay, but generally these two are perform quite similarly, even though one is 250 meter resolution and one is 30. When we look at the means, so this is comparing the means of these calibrated variables versus the measurements. Our calibrated variables are statistically similar to the measurements, the plot level measurements, for everything except for clay content, where there is some difference. But you can see that our calibrated variables are also statistically different from the raw geospatial product for all of these properties. So we are getting some differences through this approach. We then take this to the productivity analysis, so now moving into Malawi, where we're looking, this is the OLS model, looking at, the left-hand side is the value of output per hectare in log terms. And what we find is that when we're using just the raw geospatial data, the coefficient on soil quality is insignificant or fairly insignificant and relatively small in magnitude. Whereas when we use the calibrated soil quality indices, using either the 250 or the 30 meter resolution, we see a very strong significance on these coefficients, which is implying a strong relationship between soil and agricultural productivity, which is what we would expect. We also, when we look at these on the female managed and male managed samples separately, we see no significant coefficient on soil when we use the kind of these raw geospatial data. Soil quality indices, whereas we see kind of consistently strong coefficients using these calibrated soil quality indices. You can see too, so here is just a plot of the coefficients from the previous table with the 95% confidence interval, and you can see that the use of these raw geospatial variables, regardless of the resolution among these two, we get a relatively imprecise estimate and a lack of a significant relationship between soil quality and ag productivity. Coming to the gender gap, finally. So with our decomposition results, we see this gender gap of about 18.7%. And in line with the literature broadly, we see that the endowment effect does explain the majority of the gender-based productivity gap here, with the endowment making up 73% of the gap. And this 73% holds whether or not there are no soil controls or the geospatial soil controls, the raw geospatial. But when we include the calibrated soil controls, we see a slight increase in the share of the gender gap that's explained by endowment differences. To drive this point home a little bit further, we see that the soil quality index in particular makes up a different share of the endowment effect depending on the variable that we're using here. So when we are using the raw geospatial data, which is publicly available to everybody, it's more commonly used. This suggests that only up to 3.6% of the endowment effect is attributable to differences in soil quality. But when we use kind of these calibrated sources, we see that the endowment effect, the soil quality index contributes up to 27% of this endowment effect. And they're fairly similar regardless of using soil grids or this higher resolution ISDA. And when we're talking about the productivity gap as a whole, we see kind of similar differences. So if we were to rely on purely geospatial data, we would find that soil explains about 2.7%, maximum 2.7% of the productivity gap. Whereas if we are using these calibrated measures, we see that soil explains about 20%, 17 to 20% of the productivity gap, which is quite significant. So overall, we see that geospatial soil products, at least those that we're looking at here, I didn't mention before, we've also looked at the APSIS data, but we've moved on to these two sources. So looking at 250 meter and 30 meter resolution, we see significant differences from ground-based soil measures and that these have implications for agricultural analyses. We also find from this exercise that the calibration of geospatial data based on a subsample of plot level soil measurements in conjunction with survey data does show promise for improving the soil quality estimates and agricultural productivity analyses. So of course we acknowledge that additional validation is needed, particularly in other contexts. We find that the calibrated soil quality index outperforms the purely geospatial-based measures or estimates and can explain up to 20% of the gender gap that we see here. So if this kind of calibrated measure is omitted, we see a lower estimation of the role of soil health in this gap and generally in ag productivity in general. But then also, we didn't go into it in detail here, but we also see an altered composition of the endowment effect. So without the inclusion of these improved more calibrated soil quality indices, we see an overestimation of the contribution of cash crops and an underestimation of the contribution of fertilizer inputs into the endowment effect and the role that plays in the gender-based productivity gap. So finally, going forward, what will we do about this? Of course, we'll tidy up this analysis, but we also, as part of the LSMS team and through the 50 by 30 initiative, are testing kind of new innovations to measure soil health in the context of household and agricultural surveys. So we can try to make this a reality where we would have a subsample of objective measures of soil health in ag surveys, and then exploring approaches for kind of calibrating digital soil maps based on our subsample of plot level measurements for more high resolution, high quality soil data at scale. So, thank you.
Okay, just a few brief comments. So this paper, it was really nice to read it. Thanks for having giving me the opportunity to do that. It's clearly a really important topic. I think I saw two big goals from the paper. One was to improve estimates of soil quality in Malawi, which is important in its own right. And the second was to show that using it changes our conclusions about the gender gap in agricultural productivity. So I'll just have separate comments for each of those goals. So the first one, and I guess this is a writing comment more than anything. It seemed from the draft that at least I had access to, it seemed like the remote sensing data had almost no information value in Malawi. Like it looked really bad. And so maybe that could be more emphasized. Like it seemed like a lot more variation came out from the survey, which, yeah, so it seems like a really valuable thing to do. And maybe you're already moving toward this direction, but part of the paper described like a kind of a manual process of dropping some predictors in the process of creating the index, predictors that don't seem to perform well. And I was wondering if like a lasso type estimation that explicitly does that would be a good direction to go. And similarly, I couldn't tell if like that 30% split, if that was like done once. And so it was basically a regression table showing like a single set of regressions. I think sometimes what you see is people doing like multiple splits to, so you're not worried that it's just kind of a like good performance is just a property of a single split. But I think you mentioned some machine learning approaches that you were going toward in future iterations of the paper. So maybe you're already thinking along those lines. So I guess those are comments on goal number one, which is just improving estimates of soil quality. For number two, I actually thought in the table where you're using different measures of soil quality, that I think this is the endowment effect, that the part of the gender gap that's not explained by observable inputs, it didn't seem to change that much. But I had a hard time telling because the standard errors weren't shown. So there's a question like, is it a slight increase or is it statistical noise? But seeing the presentation just now, I'm thinking there's really two things going on. There's one is like, does improving the measure of soil quality change how big the gender gap is? And the second is like, okay, maybe we don't think it changes how big it is, but it changes how we think about what explains that gap. And if soil quality is, kind of a key target for closing that gap. And that seemed a lot more, that seemed more convincing. But again, I couldn't really assess the first part, the size of the gap, because unclear on the how big the statistical noise was. Yeah, and those are all my comments. I have some more minor comments, and I'll just share with you over email.
Yeah, thank you so much. I appreciate that. And yes, these have changed. I know that our findings have changed a lot since the paper that was online. So, yeah, on the variation in abscess, this is one thing that has changed. There were some issues that were resulting in lower variation than, yeah, there was some problem there. So we've rectified that now. Yeah, and I think your point is well taken on the need for standard errors and kind of unpacking this a little bit more to see if this is actually simply noise or not. But and I think the answer is it's not, but we should do a better job of showing that. So I appreciate that. Also, your comment on the multiple prediction splits. I think this is an important point. Take the chance to, if there are any questions. Sure. Thanks.
Yeah, so two quick ones. So one. Hi. So if the one is about the productivity measure from the satellite data. So, for example, in Malawi, we have all these villages, very separate plots, very small plots. Mm-hmm. I wonder, do we have an exercise which is, if you look at areas where the plots are larger or the plantation areas, would then your system work well because it's an average of 30 meter cells, and then when you go to the village, it's not going to work well unless we're like really focusing on like a plot, and then the where it's kind of where is mechanically it's probably coming from. I wonder if it is from just the fact how the plots are organized. And then one of the productivity, because you call it productivity, I keep thinking I'm going to look at hours worked in the field by women and by men. You don't have that data, or do you? And or is it more like a yield, or is it more like a hourly productivity? That doesn't make.
Yeah, sorry, I should have made that very clear. It's in this case, productivity is defined as value of output per hectare. So we do have we do have hourly labor data, which is included as a control, but we're not talking of labor productivity.
So, really neat work, super fun to think about. And frankly, it sort of makes sense to me that you can outperform with the predicted value of this thing. But I think for marketing purposes, so I agree part of it now, the challenge is storytelling to convince people that this is credible. I'm wondering if you have a story in your paper of why those parameter estimates bounce up so much when you're doing the predicted values of it. And at first I was thinking that it could be consistent with a nice attenuation bias story, but I'm not sure that works for 250 meter square. I buy it. For 30 meter square, I guess I don't buy that the magnitude of that change could be that large, or that it'd be the same if it's truly a measurement error story. But anyway, sort of, I would argue it's worth thinking about what that story is. And then just the fact that the Oaxaca decomposition didn't change, but the amount explained kind of increased proportionally for male and female itself is just sort of jarring and pretty fascinating story. And I would say leveraging that or trying to unpack that might be really interesting. And I'm sure in your paper you talk about it, but I could imagine that split sample approach. Are you stratifying on male, female so that you have sort of reasonable representation in the estimated parameters and those that you're imputing it on men and women? But I'm sure you've done that. But, all right, super neat.
Yeah.
Thanks.
Thanks, Dean.
I was curious, is this a context-specific finding, or is the geospatial data that bad everywhere? And if it's not that bad everywhere, I think that maybe points to some interesting fixes. Like if it's calibrated on, so I'm just thinking about technical or whether suppose this predicts really well in Europe and North America, and that's because it was developed for that. And this pushes to maybe someone needs to develop different context-specific geospatial models, which would be useful.
Mm-hmm. Yeah. Yeah, on this last point about is geospatial data that bad everywhere, I think it's a very good question. And I think it also comes down to, is it this bad for everything? Because in this case, our objective we would really like very high resolution data, but for some analyses, it's probably good enough, right? On the geographic issue, these data products are calibrated across Africa. So they were made, especially the ISCA, I know, is a follow-on to the Africa Soil Information Service. So they do have ground data from across the continent feeding in. I suspect that they would perform better in areas that have less heterogeneity in their soil parameters, right? You might see there's not as big of a difference. Yeah, but this is something also to be tested elsewhere, certainly. And we have some of that in the works. So we'll try to address that. Maybe next year you'll see us here. What was the other point I wanted to say? This kind of feeds in also to a point that Dean got at a little bit, was like, why would the 30-meter resolution, you might expect it to be much better, but all of these are still modeled properties, right? So the 30-meter, they're still on a certain number of kind of ground data points. So they're still all modeled estimates. So I think one thing that we can look at is the ISDA in particular. They also give you their error estimates. So we could look at how we can use that as some kind of control or some threshold around where there might be some, where it might be more appropriate to use these predictions versus just the raw geospatial data. Yeah. Okay. For time, yeah, thanks.
Okay, so I'm going to move from soil quality over to seed quality now. But on some level, this is also just generally about poor quality products sold by private firms. So, right, that's what seeds are in the context I'm going to look at it in. And so thinking about poor quality products generally, in a lot of low and middle income countries, there are a lot of poor quality products. Like I want you to think about like contaminated food products or expired medicines, or what actually was a big inspiration for the paper, knockoff electronic devices like phones and light bulbs, which is what the paper was going to be about originally. And so, like, why are low quality products so prevalent? This might be a particularly important issue in low and middle income countries, and it's because, like, fundamentally, these are products that buyers have a hard time seeing the quality of, and so the seller might have a better sense. And so we have this information asymmetry that we know, well as the lemons problem. But in many lower income settings, there might be reason to think that mechanisms that might address it in higher income countries might not work quite as well. So, for example, maybe there, in a lot of industries, there's a government agency that regulates it to solve the problem. So maybe it creates like licensure requirements or certification requirements. But if there's not sufficient capacity to monitor and enforce those requirements, or if legal institutions, if courts don't work well to enforce them, then they might not work as well to address the lemons problem. Another reason that this might persist is slow information diffusion could prevent consumer learning or firm reputation building from solving the problem. So, for example, in the setting I'll tell you about, the median, respondent did not finish secondary school. Many people are illiterate. Maybe that slows information diffusion, prevents learning. Or if less access to information technology, like laptops and smartphones, that might close off some opportunities for sharing information. Okay, so in this paper, we're going to see if improving consumer information in the sense of helping buyers detect product quality can help increase the quality of goods that are supplied. Like our hope is that if we help some buyers detect product quality, it'll encourage sellers to increase the quality that they offer to everyone. So we're going to be interested in whether informed buyers get better quality products. We're going to be interested just as much on if sellers respond to the presence of more informed buyers in their market. And we're hoping to see benefits to buyers that remain uninformed. So even though they can't detect quality, they may still benefit because sellers change their behavior. The setting, as I previewed, is hybrid maize seeds. We're going to look at hybrid maize seed markets in Kenya. And there's a huge literature on under-adoption of hybrid seeds. But we're going to focus on this consumer information angle. So can improving consumer information increase the quality supplied in the private market of this productive technology? And it's an interesting setting for the question, because I would characterize it as a poor information environment. In our setting, the median farmer buys hybrid maize seeds once per year. So it's an infrequent purchase. You don't get a signal very often. When you do get a signal, it's noisy because maize yields are noisy. And in this setting, there's limited enforcement of regulations. There are certification requirements, but they're hardly at all enforced at the retail level. So one possibility here is that buyers have poor information. It leads to lower quality and equilibrium, and that actually justifies farmers' beliefs in lower returns to adoption. Okay, so just to make concrete what I mean by consumer information, here are 2 bags of seeds from our study area. It's the same brand. It's Western Seeds. It's the same variety, WH101, and we bought it at the same market on the same day. And so the question is, which one would you want to buy? Because you have a choice as a farmer here. Does anyone want to take a shot? So it's really tricky, right? So there are small differences, though, in observable characteristics. So, for example, this one has a sticker. It doesn't say what it is. It just has like a bunch of numbers. But actually, the sticker is legally required as part of the certification process. This one doesn't, so that's a little worrying. This one has a couple typos. Opening is spelled wrong, package is spelled wrong, and this one doesn't have typos. That worries me a little bit, but it's not part of the certification process. You can get a package with typos certified. But it still makes me worried because there are stories about counterfeiters. If you looked on the bottom, this also doesn't say what like the state is, but this is a lot number that's tied to the production process, so you know which production lot it came from. And the date here is the packaging date. We bought these two packets in fall 2019, so they're actually both more than 12 months old, which is what national standards say, is how long they can be on the market legally before they're considered expired. So you wouldn't want to buy either of them, but I'd go with this one if I had to. Yeah, so this is the kind of information we're training farmers on in this paper. So what we do is we do a randomized market level information intervention. So in our sample of markets, we have 302 of them. We randomly selected which ones would get community trainings to improve buyers' ability to detect seed quality. So tell them how to buy the right packet rather than the left one, for example. And it's related to common policies. I'll tell you more about it. In all, we trained directly face-to-face over 12,000 adults, about 9% of buyers, we'd estimate. So so in the selected markets, basically, we're blasting the whole community with information as hard as we can within our research budget. And then we did a bunch of surveys and secret shopper activities to track what buyers and sellers do over the next 3 planting seasons, which is just a little over a year. And that's in case it takes some time for sellers to adjust to some sort of new equilibrium. Okay, so I'll say a few things about market structure, since I only have a few minutes. So here, buyers have a choice. They have their local seller, and all of them live within 1 kilometer of a local seller, so they're pretty close, or an outside option. They can go all the way into town and buy seeds. So their local seller isn't their only option. But the local seller does have market power locally. So the median market only has 1 seller. I'm going to think of just 2 quality levels. I know that in reality it's continuous, but I'm thinking of it as has all the visible things you should, have and is missing something. And I'm going to think of a pooling equilibrium. So sellers aren't selling higher quality seeds for a higher price. And that's just because empirically we don't see a correlation between price and quality, either in our treatment markets or our control markets or overall. So I'm not going to think about like jumping between a pooling equilibrium and a separating equilibrium. There's 1 price for all the seeds in a market. And just to fix some ideas, I want to think about the seller first deciding, do I even want to sell seeds? Am I going to stock them? Or am I going to exit the market? If they do enter the market, they'll set a quality and a price, and it's a single price for all the seeds. The buyer is going to be able to see the price, and if they're quote unquote informed, they'll also see the quality before they either choose to buy locally or they choose to buy in town. And then at the end, the buyer either gets the lower high quality product. So in our data collection, we're going to try to track all of these things. We're going to try to track sellers that enter and exit, the quality and price in the market, what buyers see, where they decide to buy, and we don't directly see the quality of the product they buy, but we're going to track their yields. So in this framework, what should we expect if the fraction of informed buyers increases? If it's small, you might not expect the seller to be induced to change any of their decisions in terms of entry, price, or quality. But you might expect more buyers to change their buying behavior. So maybe more buyers go into town to buy because they're informed and they can reject the local low quality seed. If the increase is large and upgrading quality is cheap enough for the firm, we might expect the seller to upgrade quality. So now they're selling high quality to everyone. And then more buyers buy locally because there are more informed buyers, but they can see that they're getting high quality locally, so they stay. And I'm making this blue because what we see in the experiment is closest to this version, which is the fraction of informed buyers increases by a lot, but upgrading quality is expensive for the firm. And rather than upgrading quality, sellers exit the market. They don't stock seeds. And more buyers opt for the outside option. They leave. So I'll say a few more things about the local context. So in Kenya, agricultural inputs, not just seeds, are regulated by KEPHIS. It's a parastatal controlled by the government, essentially. So seeds have to be certified by KEPHIS. Seed sellers must have to register with KEPHIS, but they have limited capacity for monitoring. The study area is 4 counties in Western Kenya. We choose randomly selected rural markets and we limit ourselves to markets with fewer than 100 shops and not within 2 kilometers of a large market, which we defined as 100 shops or more. And we're surveying seed sellers and households within a kilometer of these market centers. This map shows that the red X's are the treated markets and the black circles are the control markets where we don't spread this information. And we're focusing on kind of the last chain in the supply chain. So these tiny retail shops, a lot of them are like one person in a kiosk. We're not going to be able to directly see where all of these seeds come from. Like the picture that I showed you, we can't say like if they're expired or if they're some sort kind of deceptive counterfeit, like not actually from the company. And we also can't tell if it's a so-called gray market uncertified seed. Like maybe it came from the company, but it wasn't certified and somehow it ended up in a retail shop anyway through unauthorized channels. If you're wondering how often it is that packets lack some of the things that I showed you earlier, this is what came out of our secret shopper activity. We sent enumerators pretending to be uninformed consumers to buy seeds. So overall, 57% of the packets they bought had all of the quality markers that we trained farmers on. Many of them were either lacking an expiration date at all, or they had one, but it wasn't valid. Some of them lacked the sticker, or they had the sticker, but it wasn't a valid sticker. And the ones that are missing some of the markers perform worse in lab tests. So this is, I'm showing you the distribution of germination rates from germination tests. So basically taking samples of seeds from each packet and trying to grow them in ideal temperature and moisture conditions. Packets that had all of the quality markers performed better by about 5 percentage points in germination rate. And you might wonder, so if buying the better packet gets me 5 percentage points better germination, does that mean I'm going to get 5 percentage points better yield? Like, does it map 1-to-1 like that? And there's reason to think that actually, you know, if it's purely coming from expiration, like exposure to heat and moisture over time, that we might expect greater gains in yields than just the 5%. One mechanism might come from nutrients in the seeds degrading, and it affects the initial root growth, and in the end, it affects plant growth over up until harvest. So in one study that I found, basically they took seeds, they put them in terrible conditions in terms of heat and moisture, to the point where the germination rate dropped, and then they did field trials to see what was the change in yields, and they were actually substantially larger than the change in germination rates. Another point of reference is a similar secret shopper exercise done in Uganda, where they bought seeds from retail shops, but then they bought the exact same brand and varieties from wholesale shops and then planted them to see if they performed differently. And you can see here something like 13 to 18% gain in yield when switching from different qualities seen in the wild. Here's a flyer that we used as a teaching tool, basically, in doing the information treatment. So we walked through here are the first 7 different quality markers to look for, and the training that generally was like, do these things before you buy a packet of seed. It happened right before planting season, generally like 1 to 6 weeks before planting. I'll just point out the sticker actually gives you much of the information. If you were to scratch it, text a number, it'll tell you the expiration, here the testing date, similar to the packaging date, and a lot of other information that should match what's on the packet. And it's not fakeable in the sense that you can just make copies because it's a one-time use code. The treatment looked kind of like this. Like at around 1 or 2 in the afternoon, this would be happening with a bunch of people from the village invited to a meeting, and then the team would spend the rest of the day, and then some places got 1 to 2 additional days of our team basically walking around, going door to door, spreading this information in just the treated sites, of course. We'd estimate that we got about 9.1% of local customers. That's based on household and seller surveys to estimate, how many people usually shop locally at these markets. And I'll mention we found baseline covariates were balanced, and we were kind of worried that baseline surveys might affect people's behavior. So we also had some pure control markets where we had no baseline surveys, and we just did secret shopper activities. We didn't see differences in firms' behavior. Like, it's not like they got nervous because we came in and asked questions about maize production. So the rest of this presentation just focuses on treatment versus control. Okay. How many minutes do I have? Like 3, 4? Okay, yeah, so I'll quickly run through the empirical findings. So first, we found knowledge and usage of the quality markers increased. We found that buyers changed their purchasing decisions in response to treatment. So they were less likely to buy seeds at the local market, more likely to buy seeds somewhere else. A lot of the time, it was actually a larger market nearby, the in-town, so to speak. But little overall change in buying hybrid. Maybe a slight increase, not statistically significant. We found agricultural gains for informed buyers. So yields in kilograms harvested were higher. And just to linger on that for a little bit, we don't measure other inputs. We did ask if people used fertilizer, and treatment didn't affect if they used fertilizer. So I'll put an asterisk on the result in that we can't rule out that treatment crowded in other inputs. We didn't do a whole battery of measurement for other inputs. On the seller side, we found that sellers there was a strong seller exit effect. So about 1 in 6 or so sellers exited. They didn't go out of business, but in most cases, these were either sellers of agricultural products or general retail shops. And they exited in the sense that our secret shoppers were unable to buy seeds when they entered the market. They would say either they're not open, or they're no longer in existence, or they're just not stocking them right now, or they're out of stock. And then lastly, we didn't see changes in how often we saw the quality markers, and we didn't see changes in lab-tested performance of seeds in treated markets among the stayers, of course. Nor did we see significant changes in prices. So all of this kind of goes back to that scenario from earlier, right? So it seems like this would be consistent with upgrading quality being relatively difficult for sellers, and rather than being induced by a large increase in consumer information, but rather than being induced to upgrade quality, they choose to exit. And so overall, there's no change in price or quality locally, but the informed buyers are still able to get better quality because they have the information to distinguish between the two, and they can buy it elsewhere. So I'll just say a few things about policy implications. I think the results show that quality certification, and here especially better communications about it, can help improve agricultural productivity. One naive thing we could do is we could say, well, maybe these kinds of community training should be scaled up. And we can estimate the cost if we remove like the data collection cost, how much did it cost to just train people. It's really cheap to have one person just walk around all day and talk to a lot of people. It turns out a 1% increase in productivity could justify those costs. But of course, the cost of the regulatory structures that would enable us to spread the information in the first place, that's not included in this calculation. And I kind of wonder that the fraudsters could adapt. So you can just fake an expiration date pretty easily, which would undermine what this information treatment does if it were done at scale. There's almost certainly better strategies to spread information en masse. So maybe mass media, newspaper and radio. I think the stickers and the expiration dates were communicated not in the best way possible, especially for pretty, low education set of customers. The stickers don't really say what they're for. The expiration dates aren't clearly labeled, and each company kind of has a different formatting. Those are probably low-hanging fruit for improving consumer information here. Another big issue is we didn't get the result that we wanted. We were hoping sellers would upgrade quality and it would benefit everyone who buys from there. They're behaving as if the cost of upgrading is pretty high. So I think a key priority is figuring out why that is. Like, is it monetary cost? It could be that the difference between sourcing an uncertified packet versus certified packet might be pretty big. Like, for example, it might be almost free. Like, the marginal cost of getting an uncertified packet might be almost free because they're from last season, I couldn't sell it, and my other option is to throw them away. It could be that sellers have to exert a lot of effort to reliably get high quality seed. They might not know where to go, or they might know where to go, but they would themselves have to throw away some packets because their source isn't perfect either. We see some evidence of this because we did some secret shopper activities with the wholesalers too, and they're not perfect. There could be credit constraints. That could contribute to higher opportunity costs. So they just have a better business opportunity, and that would push them toward exiting rather than upgrading quality in response to better consumer information in the local market. So just to conclude, to my knowledge, it's the first experimental study of the market level effects of improved consumer information. We found that informed buyers respond and they benefit from this. But this large one-time campaign didn't discipline sellers in the way we hoped. It didn't bring benefits to uninformed buyers. I think it's interesting because, like I said in the beginning, I was inspired by lots of other settings where there are low-quality products sold by firms that in the media has gotten a lot of attention in a lot of different settings, like electronics, foods, and medicines. Okay, thanks.
Cool. So this is a great paper. I've seen it quite a few times when Eric and I were together at Berkeley. I thought it was, a really great sort of big idea. Can we intervene in these lemons markets and try and shift the equilibrium? So just a few comments that I had sort of looking through the paper. So the first one was just that sort of in the conceptual framework that you throw out, there's two types of sellers. Sellers who sell high quality goods and sellers who sell low quality goods. And you said that sort of in these treated markets, you would expect two reactions, either sort of low quality sellers upgrade or low quality sellers exit the market. Now, I think sort of with both of those effects, what I'd expect to see in your secret shopper data is that you actually do end up seeing quality improve in treated areas, because both of those effects, I think, push towards you seeing better quality in those areas. So the fact that you don't, I think, makes me think that there's some disconnect between the conceptual framework and your results, either that like sellers are able to sell different bundles to different kinds of people, or that there's some kinds of spillovers or something. But that was one thing that I noticed kind of going through the paper. The other thing is, so I thought that the first read, I kind of found the uninformed consumer welfare a really interesting angle. But then as I thought about it more, I kind of thought, if the government does this at scale, it's probably going to be through a radio campaign where they're going to just sort of target everyone en masse. It seems like the information is not that costly to share. Sort of what does an uninformed consumer sort of actually mean? And I think that there could be reasons maybe it's just sort of costly to make the effort to look for the things, but maybe sort of the framing of uninformed. Maybe it's like a behavioral thing where some people just won't use the information but you give them. But I thought sort of a little bit more information maybe about why we care about uninformed consumers could be interesting. The other thing is I wondered, sort of going through it, was that you sort of set this up as a problem where there's these sellers who know what kind of product they're selling and buyers who aren't able to, sort of a classic lemons problem. But I didn't see sort of a lot of evidence in the paper actually for sort of how informed sellers were. And that might be sort of maybe another place, or sort of maybe an easier place to intervene in the market. And sort of, I mean, sort of at the beginning, you said, you know, sellers just can't build reputation in this market because the production process is so noisy and farmers won't attribute sort of what they end up buying actually to the person they buy it from. But maybe that's not true. Maybe sellers just have no idea what they're doing. And if you did help to educate them, they could sort of use these private sector mechanisms to build reputation or whatnot. So I think just some more context about how that much they know would be interesting. And then sort of the final thing going back to this reputation thing was sort of, again, there's this idea of it, you know, given the yield gains are so big, it seems like as a seller, if you could, you know, get a reputation for selling good stuff, you could increase the price and people would be willing to pay for that. And, you know, I think it's true, like farmers may not attribute sort of all of the yield gains to the, just because the production process is so noisy. But something I was thinking about then is sort of, what about your intervention? Are treated farmers going to keep doing this, or is the production process so noisy for them, but the next year they just sort of give up and say that was completely worthwhile? So I thought like completely worthless. So I thought maybe a little bit more of a discussion of sort of what farmers learned from this and whether this was sort of a one-time intervention or something that would need to be sort of repeated would be great. But I've always thought this is a really big and ambitious project and really like it. So thanks a lot.
Okay, yeah, thanks for the comments. I could respond to that really quickly. I think it sounds like I need to do a better job explaining like the conceptual framework. So, I mean, I've been thinking of like, rather than two types of sellers, really there's only one type of seller. Like they're not really differentiated. And in the data, I think that's supported by our secret shopper data, where like if there really were like good sellers and bad sellers, like there's some sellers that are just like, you know, they'll follow the rules and then they're just bad people. Then in our secret shopper activity, I would have expected, like they observe 2 packets each at each seller. I would have expected a lot of sellers to have 0 like packets with all the quality markers and a lot of sellers with 2. But instead we see like something pretty much consistent with random, you know, selection of packets. Like there were 0s and 1s and 2s and a lot of 1s. So yeah, I think I'll go back in the paper and think about how to rewrite that. In terms of this idea that we can get to 100% informed buyers, like under a real policy, and the uninformed buyers are kind of irrelevant. I think there's something to that. I mean, there are other contexts where that's certainly happened. I think in our context, one thing we noticed is almost all the information gains happened with people with at least a primary school education. That's about 2/3 of people in our sample. And for many measures of information retention, we actually didn't see statistically significant effects on that for people with less than a primary school education. So for some people, I think it actually is really hard. And just thinking of like teaching my grandma how to use a laptop, like I think many of these things might seem really simple, but it can be a challenge. I also wonder how much the sellers know. In the end, I kind of alluded to like maybe we could think of that as like a cost, and that's kind of why they're behaving like it costs them so much to upgrade quality. Another way to think of it is I would think of our treatment as also improving seller information. Like there's just no way they didn't also get the information that we're usually doing, like the picture of the meeting I showed, like right there in front of those shops, because these are pretty small markets. And then we would come back for day 2 and day 3. I think more about the reputation building and persistence of effects. I would love to go back and get like, 3 years later, what are farmers doing? Yeah.
You have thought of concern on the equilibrium. Hi, on the general equilibrium effect. So one is the price difference. If the local sellers are affected and they shut down, then the price for the local buyers has changed. The distance, the distance to the main market, and if this really, if you go in general equilibrium, like if this affects the sellers properly, meaning now the local buyers don't have the option to buy locally, that could be a concern. The shop that sells maize could be the shop that sells medicine. I don't know, something.
Yeah.
And on top of this, if you think of an intervention that goes nationwide, and then you could be shutting down the local, suppose only very few people are able to sell the good quality stuff, they all have to go into the town. So it could be completely altering the way these things are distributed and sold. So I wonder how much, what has gone through your head about that? Or
Yeah, I think you're right in that, like maybe if the intervention didn't reach like 9% of buyers, but reached 100%, and not just in this market, but all markets, we would see quite different things. I think we take one step toward general equilibrium, like one step toward just like an individual level treatment here to study how sellers respond. But I'm pretty sympathetic to like, we have to make some assumptions if we're like trying to take these results and thinking about what if it was nationwide, all markets, everyone. Yeah.
Hi, thanks, Eric. I'm just trying to understand the exiting of the sellers. So do you know where the corruption is happening? Because you kind of talk about high quality, low quality, but I was like, oh, this could be an intervention to just inform people of corruption on anything. And is there corruption to the sellers? So do the sellers also are kind of buying stuff and thinking they're getting high quality product? And in Kenya, is there sort of the cooperative, can you only source seeds from a few cooperatives or a few wholesalers in the market? Is there any kind of competition effect? If you've got more sellers, then the sellers themselves can go and get better quality seeds from various people. So maybe the corruption is happening to the seller. Once they try to get the higher quality thing, they're just told that they can't buy it. And so therefore they have to exit from seeds. So I'm just understanding where the corruption is happening along the chain is useful. Thanks.
Yeah, we have a limited view into it, but I'll tell you what I know. And this is mostly coming from focus groups we did with sellers. So they're not part of the study, but we're just trying to get them to open up about how they make these decisions. So some of them might not know, and we can't tell if they're trying to protect themselves or if they really don't know. Some of them have a choice. So anecdotally, like right before planting season, there are unauthorized distributors. They go around in vans and they make a deal like, hey, buy from me instead of the authorized distributor. I'll sell them to you for cheap. And if you don't sell them at the end of the season, I'll buy them back from you at the end of the season. That's like one unauthorized source. There have been counterfeiters that have been shut down by authorities, but we don't hear about them until like there's one that got shut down right before we started the project. But, it's not like we can go, we didn't, play like undercover, we didn't do an investigation of that. And then there are expired seeds. Like when we take the quality marker results at face value, like they're not counterfeiters who are just not being very careful about that. They're just literally expired seeds. Then I think a lot of seeds get unsold, and there's an imperfect mechanism from seeds manufacturers to buy them back. And either the same seller is selling them again, or they're selling them to someone else who then sells them, or selling them to an unauthorized distributor who collects them and then resells them. That, at least from the my conversations with people throughout the project, that seems to be part of the story.
Hi, it's a very short question as a curiosity about the fact that you talk about share of buyers, but maybe there is like central buyers that are their importance in terms of as buyers can change the seller more than any small buyer. So the cumulative effect is not just the sum of the share of information or the relative importance of buyers for the seller. But I don't know.
Yeah. Well, what do you have in mind? So there might be like a very important buyer.
Yeah.
Not just because they're big, but
yeah,
they're important in some other way.
They are all in the community maybe because they are central and they can inform around. But I don't know. It was something like that.
Yeah, thanks for that. We tried to tap into that. We did get the impression that some people are more important for sharing information than others. And so we really tried to tap into that with you saw the meeting of like trying to invite influential people in the community to like definitely get informed.
And then I just a curiosity, how long you were there to observe the changing in the attitude in buying? Say because you went there to the period before they had to buy to harvest, and then you stay.
Yeah, I didn't show the timeline, but we did. We started this in late January 2020. Most of the treatment was in February 2020. We managed to finish just before COVID shut everything down, so we were very lucky. And then everything else was phone surveys or the secret shopper activities.
Okay, last one.
It's super interesting stuff. Any sense of willingness to pay all these farmers for better seeds?
There's another paper that did an exercise where it's like they showed a video talking about, I forget which, I think it was 2 or 3 of the 7 quality markers. And then they did a willingness to pay exercise, and people were willing to pay a little more for packets with the quality markers. We didn't do a willingness to pay exercise, but I think that other paper was also in Kenya. Yep. Yep.
Thank you. Okay, great. Thanks everyone for sticking around. So this was my job market paper this year. It's Undertraining by Employers in Informal Labor Markets, Evidence from Burundi. So it's joined with Michel, who's here today. He was also on the market this year. He has a really interesting job market paper about whether sort of youths in university invest in the right kind of skills right after university. So definitely check that out. And he's also presenting on Tuesday. In addition, this whole presentation is just an advertisement for Michel. In addition, I work with Louisa, who will be on the job market next year, and Pedro Nazo, Pedro Nazo is also here, but he's not in the room, so he gets no shout out. So, okay, so the starting point for this paper is the fact that the majority of employment in low-income countries is traded through short-term informal contracts. So in rural areas, a lot of labor is traded through spot markets where employers and employees come together for just a day or two and work, and then they unmatch and the worker goes and works somewhere else. And in this context, we see very minimal long-term contracting. Now, in urban areas, you do see more, longer-term contracts, but even in that setting, we tend to see sort of higher turnover than we would see in higher-income countries. So what we ask in this paper is whether, given this labor market structure, employers may not want to train workers in productive general human capital because the worker is likely to leave them and they won't end up getting any return from this training. This idea links back to sort of an old and rich labor economics literature going back to Gary Becker and Arthur Pigou that suggests that this mechanism may actually lead to meaningful distortions in the economy, but there's limited empirical evidence showing that this is actually the case. And this could be quite important in low-income countries because if employer-sponsored training is actually an important source of human capital investments, this might contribute to sort of a low level and limited growth of labor productivity that we observe in the data. So in our setting, we're going to focus on agricultural casual labor markets in Burundi in partnership with an agricultural NGO, One Acre Fund. So I think this is an important setting for 2 reasons. First of all, for all of the talk about urbanization and whatnot, the majority of the global extreme poor still trade their labor in rural areas. So if you care about the poor, this is an important setting. Secondly, we're going to focus on kind of an agricultural setting, and there's a huge development literature that explores why it is that agriculture in sub-Saharan Africa is relatively unproductive. So in this setting, 3 facts sort of motivate our experiment. The first is that we see a partially adopted improved agricultural technology. So in these villages, employers adopt row planting only partially. So row planting is an agricultural technology that has been shown to improve farm yields by 30 to 70%. And it's something that training requires around a day or so to learn. And what we see is that in our data, employers in these villages adopt row planting on some of their fields around 80% of the time, but on all of their fields around 20% of the time. So it seems like they know how to row plant, but they only partially adopt it. That could be driven by a lot of different things, but what's interesting is that people tell us that a big constraint for them is that casual labor markets in the village are unskilled. People don't know how to do row planting. So these labor markets kind of function as you might expect. Employers and employees typically work for just a day or two. A lot of labor in this context is family labor, but for these larger employers, there's an important hired component, maybe around 20%. So then we ask employers, okay, so if the casual labor market is important and unskilled, why don't you train them? And the majority of employers say something that sounds along the lines of I won't get any benefits from training because if I train that worker before the planting season, they're unlikely to come back and work for me, and I won't get any benefit. And so our research question is whether farmers underinvest in training laborers because they don't capture the returns from training. We won't be able to answer in our paper why it is that employers don't write longer term contracts. We're going to sort of take the fact that employers use these short-term contracts and given and sort of try and understand whether this leads to meaningful distortions. The way we answer this question is with two field experiments. In the first field experiment, which is at the level of the local labor market, we're going to induce some employers in that labor market to train laborers and then just look at what happens in the labor market and who captures the returns from that training between the employer who trains, the worker, and other non-training employers in that same labor market. In the second experiment, we're going to do something very different. We're going to go to other labor markets and try and make workers more likely to go and work for particular employers. From these two field experiments, we're going to show you two results that are consistent with this idea of too little employer-sponsored training. In the first experiment, we're going to show you that there are large and positive returns from training, but a lot of the surplus from training is captured by other employers, not by the employer who does the training themselves. We're then going to show you that if employers know that workers are going to return, they become willing to train. So they perceive positive returns to training, but they don't believe that they'll capture that. Why does this matter? What it shows is that in these kinds of institutional environments, employers may have insufficient incentives to make sort of high social return investments, and that this wedge between sort of private and social returns may be a meaningful impediment to making these kinds of investments and something we should explore from a policy perspective. Okay, so in the paper, we sort of outline a very simple conceptual framework that delivers sort of a few sort of important predictions that we then test with our field experiments. This is sort of a framework where firms train workers, but there's too little training in equilibrium. So the first prediction that this kind of model delivers is that if we see employers training workers, we should see that a lot of the returns from that training spill over to others, either to workers through higher wages or to other employers who end up hiring these workers. The way that we test this is through what we call a spillover experiment, where we're going to get some employers to train workers and then just like measure in that labor market who captures the returns from that training. The second thing we should see in this model is that if employers do become more likely to have workers come back, they should become more willing to train them. So the way that we do this is with a second experiment where we provide very high incentives for workers to go and work for particular employers and see whether employers become more willing to train that worker. Finally, sort of the third prediction of this kind of model is that if there's too little training, we should see that the returns to training are high compared to the cost of training. And I won't show you this today, but sort of an exercise we do in the paper is we do aggregate up all of the returns from training and compare it to the cost. So let's go through these two experiments. So our spillover experiment is going to be an RCT that we do at the village or local labor market level. And we're going to sort of borrow a training protocol from our partner organization, 1 Acre Fund. We're going to recruit two kinds of farmers to attend this training event. The first are trainer employers. So these are employers from the village who know how to do row planting themselves, but regularly hire labor at planting time to help them on their fields. We then ask these trainer employers to identify what we call trainees. So these need to be individuals in the village who work for others as laborers and don't know how to do row planting, but who the employer would actually be interested in hiring. We then sort of take these pairs and we provide them large parcels of land away from other farmers. And then sort of the key difference that we're going to do as compared to sort of what 1 Acre Fund does normally is that we're going to sort of then encourage the farmers to train one another. So the way that we do this is as follows. So we get these pairs to show up. And on the first day, we just ask the farmer to train the worker in a placebo task like composting and harvest storage. And then we provide two sets of incentives for farmers to come back the second day and train the worker more. In the control group, we tell the trainer or employer that they can come back the next day and train the trainee if they want to. There will be land and equipment available. And then the trainer or employer is just given an unconditional financial incentive. In the treatment group, the only difference that we make is that we make that payment to the farmer conditional on them coming back and training the worker the next day. We then measure outcomes over the course of the agricultural year. So we're going to sample 80 villages across 2 provinces in Burundi. And kind of the key advantage of this setting that we have is that in this setting, villages constitute a local labor market. So there aren't these spillovers. And what's nice is that because these villages are not so large, you can identify in these villages not only the direct effects of training on the trainer and the trainee, but also spillover effects to others in the village. And so that's exactly what we're going to measure after we do this training, are the effects for the trainers, for the trainees, but also for other employers in the village who didn't do training themselves. We're going to measure returns then for this set of 3,600 employers and workers and just look at how much of a returns from training the employer doing the training captures. Okay, so to show you sort of our key results from this experiment, we first show that training happens in response to incentives, no surprise, and that it looks like the training is effective. So if you pay employers to train, they're more likely to come back the next day and spend at least half a day training the worker. There's a big first stage. And maybe more importantly, and maybe a little bit more surprisingly, this training is effective. So the second chart, what it shows is for the trainees, how many days during the next planting season do they go and do row planting in the village for employers? And you see that there's a pretty large first stage there. So in the control group, they spend on average around half a day. In the treatment group, that increases to almost 4 days. So then the question is, okay, so who ends up hiring these newly skilled workers in these markets? So we find that trainer employers do hire more labor and increase the adoption of row planting in these villages. So what column 3 shows here is how many days in total do the employers who trained workers themselves hire to do row planting. So in total, they're able to hire 46% more days of labor during the planting season doing row planting after there's this skilled labor in the village. What column 1 and 2 is decomposing is who exactly are they hiring? So in column 1, what it shows is that they're able to hire the person they trained themselves for around half a day more. And then the additional effect that you're getting is from a spillover from there being other trainees in the village now. So column 1 shows that partially this is them hiring back their own trainee, and column 2 is showing that then they get a little bit on top because there's this other skilled labor that exists. And this hiring then enables them to adopt more row planting on their field. So after training these workers, they adopt row planting on around 19% more fields. Not everything is great, though, because it seems like after being trained, it becomes harder for the employers to rehire these workers. So we ask employers here, did you try to hire the worker you trained and were you unable to do so? And that increases a lot in the treatment group. So it seems like after these workers become trained, they become in demand in the village and it becomes harder to rehire. Sort of maybe consistent with this, we then see returns from this training accrue to other employers in the village who didn't train workers themselves. So here's sort of the same table for spillover employers. So these are other employers in the same village who didn't train workers. What we see is that they hire a lot more labor on their fields as well to do row planting, around 60% more days. And this enables them to adopt row planting on 24% more fields. I won't show you today, kind of in the interest of time, but in the paper, we also sort of go into trying to measure the returns, sort of a profits and looking at the incidence of training. What we see is that these non-training employers, the profits on their fields look like they rise by around 9%, and they capture around half of the total surplus from training. So we have this result that when training happens, it looks like there's positive surplus, but a lot of his surplus is not captured by the employer that trains. So now we want to look at, okay, what if we change the labor market? What if the employer could capture more of a surplus? Would they then become more willing to train? We can't do that in the same experiment because one experiment requires looking at the labor market as it is, and the other one requires changing the labor market. So now we do a second experiment to get at this. So how do we do this? So we identify trainers and trainees in the same way that we did in the spillover protocol. So we have the same selection criteria. We then provide different, what we call, I guess, labor guarantees to the trainer and trainee pairs. So in the control group, trainer, employers, and the trainee come together, and we tell them both that the trainee who they brought is going to receive just an unconditional lump sum cash transfer during the planting season. In the treatment group, the only difference is that now this cash transfer to the worker is made conditional on that worker going back and working for that employer. So we have sort of differences across these pairs and the incentives for workers to go back and work for particular employers. These cash incentives are quite large. It's not like we just give them a little bit more money. We increase the daily wage by around 70%, so like almost double. So there's these big incentives for workers to go back and work for particular employers. We then offer in these villages a training event that we tell these pairs is going to be held over the next 2 days. And this training event is kind of the same as we did last time. We provide land, we provide equipment to do training, and we don't do any training ourselves. So we tell people, look, we're going to provide this venue where you can train workers yourself in this thing if it's worth your time. And it will sort of reduce some of the hassle costs of doing so. But nothing is conditional on training. So no one has to show up. People in the control group can show up if they want to. People in the treatment group can show up if they want to. But nobody has to show up to this. And then what we measure is who is more likely to show up and train their worker in response to this treatment condition where the worker is more likely to return. And then what we measure is sort of how likely is it that the employer and the trainee show up, and the employer sort of spends at least 3 hours training the worker. And we see that this becomes much more likely when the employer has this guarantee that the worker is going to come back. This seems to be a meaningful decision. So then we go through and actually implement these contracts during the planting season. And around 90% of the employers who train the worker actually end up rehiring them at the time. So it doesn't seem like this is all driven by like a demand effect. It seems like, people train the worker and then they appreciate that. Admittedly, this is a very large treatment effect. So maybe you think this is driven just by some kind of demand or confusion or whatnot. So one thing that's nice is at baseline, we have a measure of how concerned employers are about workers returning. So at baseline, 55% of employers either say it's hard for me to get workers to show up for me during the planting season, or I can get workers to show up now, but if I train them, they're in high demand, and it will be really hard for me to get them to show up. And what I didn't put the figure, but what we show in the paper is that this response in terms of training is entirely driven by these employers who have this concern about the workers showing up. So employers who say that they're concerned about the worker showing up come and train the worker about 80 percentage points of the time, and employers who don't only come and train the worker about 30 percentage points of the time. So those are kind of our core results. Then what are sort of the takeaways? So sort of the main takeaway we want to have in this paper is that given sort of the structure of a labor market in low-income countries, this wedge between kind of a private return to making training investments and the social return to making training investments may be a meaningful impediment to making high return investments. Admittedly, our setting is a little strange. We have a particular agricultural technology in Burundi, but what we would argue is that sort of the features of this labor market are fairly universal. The fact that there's a lot of turnover, the fact that there's informal contracting, and so we don't think of this as just sort of a test in this setting, but likely to sort of be a meaningful impediment in other settings. And then then don't worry about the last two things. So they're not so important. So I think also I don't have a discussant, right? So I think I'm done. So if anyone then has okay, so yeah, thanks everyone. So if you have any questions, feel free or come and grab me later. And yeah, okay.
Thanks so much. My name is Sadib Kılıç. I'm from the World Bank. I have many questions for you, but I'll try to be constrained. Okay. So on this 1 acre fund, kind of piggybacking on the 1 acre fund infrastructure, I wondered whether there's anything about this particular context that would signal any of the impacts that you're receiving, any of the impacts that you're seeing to be an upper bound vis-a-vis other interventions that may have been carried out. So maybe if you could share that context, that would be helpful vis-a-vis 1 acre fund. Second, I wondered, so I was partly chuckling about this, but this is a very specific skill, like row planting. Mm-hmm. It takes 3 hours to train people on. What are they going to do with this skill if they're not applying it? So if you could tell us a little more about why employers are so concerned about laborers not returning as a part of the training that receive, as a function of the training that receive, I think that would be helpful. Related to that is whether these trainees can be employers themselves.
Yeah, okay.
So because in these villages, they may have farming of their own. So yeah. I wondered a little bit about what the spillover sample is capturing itself, but in general about this non-return and whether that has actually anything to do with trainees having their own ag activities to tend to.
Yeah.
So if you could expand on that.
No, those are all really good questions. So maybe the last one first. So I think kind of in the interest of time, I focus just on the spillover to other employers here, but you're absolutely right. So what you really have in this context is not employers and workers. You have large farmers who farm their own land and then hire in additional labor to help them, and then smaller subsistence farmers who have their own farms that they plant and then will go and work for others once they finish. So you're absolutely right. So, one thing that's sort of unique about this context is, in a lot of these training things, people think, the person who does the training has some monopsony power because it's hard for the worker to signal the skill to other employers. In this case, even if you're worried about that, you might worry about the worker not coming back because, like you say, they might say, oh, this technique is really useful. I'm just going to spend a lot more time on my own farm doing row planting rather than coming back and working for you. So I think that's absolutely right. There's kind of this, in the paper we go into it a lot more, but there's kind of two sources of return you might not capture. The fact that the worker gets sort of wage returns and farm returns, and other employers get farm returns. In terms of sorry, there's two more questions. In terms of the context, so I think the way that 1 acre fund diffuses sort of these trainings in these villages is fairly similar to the way that kind of extension and NGOs in general diffuse trainings in sort of new technologies in sub-Saharan Africa. So 1 acre fund kind of has a membership. They only operate their trainings for their members. And so they train them, and then sort of a puzzle for us was, if this training is actually high return, why does it not seem to be sort of diffusing out beyond their members? I think of that context is fairly similar actually to other agricultural contexts in sub-Saharan Africa. Like the way that I think most technologies are diffused is that people seem to believe that, let's go and train sort of a few farmers in this village, like a few role models, a few leaders, And if a technology has high returns, people are going to come to them and seek it out if they're well known. 1 Acre Fund, I think, to some degree operates under the same assumption. I think there's plenty of literature showing that that's just false. Technologies seem to spread much slower than canonical models of social learning would predict. And so I think our paper is contributing sort of one reason and one mechanism for why that is. The second question, okay, yeah, so I mean, I think your second question, like to some degree I get this a lot, is just, you know, what is the opportunity cost for farmers? Like, why don't you just train like 20 workers? You know, like you're a farmer, like, you know, most of the time you're just kind of sitting around not doing anything. Like, I think, you know, I don't think farmers see their time that way, you know, like I think they see an opportunity cost to their time. You know, if it takes half a day and this worker is just not likely to come back to me, that's, you know, a cost benefit analysis that I do. And I don't want to waste half a day. I'd rather go into town and sell some vegetables, or I'd rather hang out with my friends. That's a lot more fun than, you know, hanging out with this kind of poor, undesirable person in the village. And, which is kind of a dynamic here. It's, you know, the employers are all the rich people and the laborers are all the poor people. And, you know, so yeah, you cannot rationalize our results if you assume sort of the opportunity cost for farmers of training is zero. So I think that farmers, and I also believe it's not, but, you know, a lot of people seem to have that belief. More questions? Mm.
It's very surprising to say, I mean, they don't understand that even if the cost would be amazing to want to train any kind of workers, even if they work for you for one season and they feel so much.
Yeah, no, I completely agree. I mean, I think sort of, I think like, mm. So, no, for sure. So, no, for sure. So, one thing I would say on this is I think a lot of people do have this impression that, you know, this is an issue. This kind of mechanism seems more likely to be an issue for longer, more costly trainings. The literature that exists, like in Europe and the US, also suggests that you have like a same kind of similar set of issues for like temp workers. So for example, like David Autor has a paper about sort of missing markets for training of temp workers in the US. And the market that's provided there is, you know, like the median training that is provided by the intermediary there is like 8 hours. So it's not 3 hours or 4 hours, but it's not that much longer. So I think that just sort of in these settings where there's high turnover, you can end up with, you know, relatively low cost things that could have high returns just because. Now, I think maybe like the question that I wrestle with in this paper is why is there high turnover? Like, why do people not write relational contracts? I think that would, you know, that is something that, you know, we can't answer. I tried to sort of frame that up front. We have a little bit of evidence for why that happens in the paper. But to me, that's the big puzzle is, you know, if there's a contract with so much surplus that could be written, like why doesn't that end up getting written? I agree with that.
Thanks. I thought that was very interesting. I'm wondering if you've thought about whether or not your intervention is kind of a transitory shock, and if you were to go back and look, things would have returned to the previous steady state, or if this is, and if there's enough of a holdup here that the intervention itself moves to a new steady state. And obviously the costs of going back and revisiting via survey are prohibitive, but given that you have something with a pretty decent spatial signature, you could consider with some effort validating what's happening, what things look like post-intervention with remote sensing to see whether or not there's clear signatures of row cropping versus not? Because I think that's a really interesting question that speaks to a much bigger policy implication here, is whether or not this is a nudge that moves you into a more desirable steady state that's welfare improving, or whether or not this is kind of just another development intervention that goes back to normal once you remove money.
Yeah. Okay. No, that's a good point. So, two things on that. The first is that it's actually quite hard to detect row planting from space. Sort of, I've like is granular at the granular, or I guess sort of at the level we would need to observe. I think the cost to me of sort of buying that data would probably be prohibitive. We did talk to a few people about it. We did go back and do surveys kind of a year later, and we found some persistence of the intervention, but also some depreciation. So things didn't revert exactly back to the control, but things were not as they were after year one. So I agree with you. It would be interesting to look at to what extent things fully go back, so like what the dynamics are even more over time. But I think, like you say, I think we won't probably ever have money to do that. Maybe in the interest of sort of time and people's interest, why don't I wrap up here? And if anyone else wants to come and ask me questions, I'll hang around, or any of the speakers. And otherwise, thanks everyone for the comments.